Presume that there are two particles up in a certain way. They are now put far apart from each other, and we only know the state of only one of these particles. Is it still possible to determine the other state of the particle? Well, the answer is yes, and this is what you call quantum entanglement. What is quantum entanglement? If two particles are entangled, meaning their quantum states are strongly correlated and become unified, then measurements of one of the particles automatically influence the other, no matter how far away the particles are from each other. Let's put it into simpler terms. I have a spoon and fork, and I place them into two different containers. After that, I shuffle the containers. If I open a container and finds a spoon, then without opening the other container, I can instantly know that it contains the fork. This will remain true even if we put the containers light years apart. That's because the spoon and fork are entangled entities. But how do particles entangle? Let's say we need to produce a pair of photons. Entangled pair of photons can be created by spontaneous parametric down conversion. This involves firing a single photon to a nonlinear crystal to produce a pair of photons, which remain correlated even when separated by large distances. Particles have a property called spin. Before we measure it, it can be in any direction. To measure the spin, we need to specify the direction in which you wish to measure it. If we measure it horizontally, it can be left or right. If we measure it vertically, it can be up or down. Note that one of the key facets of quantum mechanics is that it is intrinsically probabilistic. We can't know, even in principle, the state before we measure it. Say we have two entangled particles, A and B, and are a light year away from each other. Without knowing the states of either, we measure the state of A. If particle A's spin is left, then particle B's spin will be right. As they're entangled, we immediately know the other state of the particle. And here's the spooky thing. When the measurement is made in one part of the universe, quantum information can be sent to an entangled particle even in another part of the universe.